for you. First of all, I've got Matt Curry.
Hi, Dave.
Hey, Matt. And Matt is our new account manager, product specialist for Sorbent Technologies in the Mid-Atlantic region. And he'll also help with other activities. Matt's got 20 years of bench experience, master's in chemistry. He is an organic genius when it comes to purification. That's right, Randy, big eyes and all, organic genius. Woo, woo. And he will definitely be available for assistance in helping you optimize and to do method development for your compounds. Anyway, so what we decided to do last time, if you recall, we were talking about TLC to flash cartridges. And since I have Matt here, we figured we'd talk a little bit about TLC. Matt would give you some of his own thoughts on basic spotting techniques, concentration zones, solvent optimization, and maybe using different types of compounds and also different type of modified layers. And then from there, we're going to talk about going from TLC to flash. So, Matt, looking at just basic spotting techniques, when you were in the lab, how did you go about that? What was your way to really do optimization?
With optimization, I always spotted the reaction with all the starting materials and in co-spot. So if there was 2 reactions, it was a total of 5 spots with the reaction in the middle, 1 starting material on one side, 1 starting material on the other side, and then between each starting material and the reaction, there was a co-spot in which both the reaction and the starting material was spotted.
Cool. And would you ever use, when you were using the little capillaries, is that what you used?
Yes, glass capillaries.
Would you spot it or would you broadband it? Because I heard broadbanding sometimes actually helps give a better resolution.
Always just spot it.
Spot it.
We were just trying to get a quick and dirty look at it.
Thoughts on concentration zones?
Concentration zones, if you're doing prep TLC, concentration zones are very nice. For those of you who don't know, prep plates are much thicker, and if they have a concentration zone, what you can do is you can spot your compound in solvent all over that zone, and then when the prep TLC starts to run up, it'll all run together, and it'll start all together right at the start of the silica gel on the plate. Nice.
Any thoughts on for solvent optimization? That's always a little bit tricky, looking at the best way to, I think the first thing we try to do is get some type of resolution, and then you may look at how can I optimize that solvent system.
Yeah, oftentimes what I do is I run my TLC plate with the 5 spots on it. I run it in 30% ethyl acetate hexane, 50% ethyl acetate hexane, and 70% ethyl acetate hexane, and see where the spots go, and even if the compounds were resolved with one of those 3. If they resolved one of those 3, I knew I could run a gradient of ethyl acetate hexane, and I'd be able to separate.
Cool. Any thoughts on different types of compounds? I mean, let's say we're using a more polar or more non-polar compound. I mean, what was your thoughts on using a silica plate versus maybe a C18 plate or another functionalized plate?
Well, I did a lot of heterocyclic chemistry. I was in the pharmaceutical business, and you can't, with heterocycles, you don't really have a good guide sometimes as to how polar or non-polar things are. So if I run them up in ethyl acetate hexane and I didn't get any separation, I then move to methanol and methylene chloride. So 5% or 10% methanol and methylene chloride is much more polar than the ethyl acetate hexane mixtures, and will pull polar compounds up the TLC plate so you can separate them. And you can use those solvents again for flash chromatography.
Awesome. Well, listen, this is a quick little blip on TLC. On a next run or a next video shot, we'll talk about taking that TLC info and putting it on a flash cartridge. Otherwise, out for now, quick little ending lick for my buddy Narendra.